Welcome back. This video will introduce two concepts. The first is the idea of a conditional loop, that is a loop that only iterates if its condition is true. The second is the idea of a nested statement, which allows you to write complex looping behaviors. The idea of a conditional loop, which is often called an indefinite loop, is that they have a condition that determines if the body of the loop will execute. This means that as long as the condition remains true, the loop will repeat. At some point, the condition must become false, or else the loop will repeat forever. This is sometimes known as an infinite loop. And there are plenty of use cases for this, such as waiting for some user input, or checking a sensor value over time, or even optimizing the values of some function until some threshold is reached. Python's conditional loop is the while loop, or the while statement. The while loop looks a lot like an if statement. It starts with the keyword while, and then is followed by a conditional expression and a colon, and then contains an indented body that can have any number of statements inside it, all indented at the same level. The way this executes is that first, Python will check the condition. If the condition is true, it will execute each of the body statements in succession. After all of those body statements have executed, it will come back and check the condition again. When the condition becomes false, if ever, it will go on to the next statement at the same indentation level as the condition. This idea of indented statements or nested statements is really very important, especially when we're dealing with loops, and often found in the while loop. The while loop also has the frequent need for what's known as a break statement that allows a loop to end early. And so it's helpful to consider what statements belong to which other statements, and also what the break statement would do when it's encountered. So let's take a look at this diagram here, which represents an abstract set of indented statements in Python. The if statement here, that reads if condition 1, contains only a single Python statement, this while statement, which includes while condition 2 and its body. The while statement contains two statements. One is this for statement and its body, and the other one's this if statement and its body. This for statement contains a nebulous body here that would consist of multiple statements, and then it's followed by an if statement that contains the word break, which is the Python statement that can end a loop early. Importantly, this break ends the current loop, whatever that happens to be, the innermost loop that you're on. It does not end a loop that it's contained within. So if this while loop were contained, if this read while condition, this break would only end the while condition 2, not the while condition 1. So let's head over to Jupyter now and explore while loops in practice. All right, let's write a semi-useful program. This semi-useful program is going to try to see how many numbers in succession, so counting up how many do you have to add together before the number becomes greater than some target number. So let's set a target number. So let's set our target as some very, very high number. And we can say how many times or how many iterations of a loop where you add 1 plus 2 plus 3 plus 4 and so on and so forth till you get greater than this target. And so I'm going to keep a running sum, or running total. I'll say total here. So total is 0, and then I is going to start at 0. We can start at I at 1 actually. And I'll say while total is less than the target, then total plus equals the count that we're on. This is I, and then I plus equals 1. And then I will print the I when we're done to say how many times it took. And it looks like it takes 261,000 loops, iterations. And you can see now just how fast Python is, as long as you're not printing things out every loop. That calculated almost instantly. This is a very, very high number, and so I can make it even bigger, and we can run it. This will take longer, because it's taking a long time to get up to that size number. But Python can have any arbitrary size number of integers, and so this will eventually finish. It is just taking a long time because that's an astronomically large number, and it's taking a long time for Python to calculate it. Actually, it's a little bit surprised it's not done just yet. But I can begin running the next line of code while that is running, and so eventually we will get a printout there. But I'll show you the next version of this loop. So you can do this in Jupyter, it's no problem. This code cell is going to execute, and then it'll move on to the next code cell that executes. So let's write a different variant of a loop. Let's write one that doesn't end until I tell it to end. So let's say we are essentially getting input from the user. So while true, we can say selection equals, there you go. It took, this one finished, by the way, it took 261 million loops through to get to this target number with this process. So back down here, while true, the selection is going to be some input here. Enter a number between 0 and 9. And then I can say if the selection is equal, I'll put or q to quit. If the selection dot upper, so even if they enter lowercase q, it'll work, is equal to q, then break and print goodbye. So let's run that, enter a number between 0 and 9, and so I can enter 9, anything I want really, but if I enter a Q and hit enter, it says goodbye. And so this is a very popular version where you say while true, and then you decide when you want to exit or under what conditions you want to exit this loop. All right. In summary, this video explored while loops and introduced nested statements as well. The while true loop is especially useful to allow a process to continue indefinitely until some condition is met, in which case the break keyword can be used to end the loop immediately.